This is a sustainable engineering solution for the people of the Mekong province on the Mekong Delta. The design area we are focusing on is the production of electrical energy from sustainable sources such as solar energy and wind power. The Mekong Delta has good electricity coverage, with approximately 80 to 90% of households being connected to the grid. Electricity is predominantly used for lighting and charging mobile phones in a typical household. Some households may also have a TV. The main source of power in Mekong Delta region and Mekong province is electricity from power stations. However, they still face the global problem of making energy usage sustainable. City prices for electricity are about 100,000 VD per poor household, and prices range from 3,000 to 5,000 VD, which equates to around 14 to 23 cents per kilowatt hour. Next year, the price of electricity is predicted to increase by 30%. Connection fees to electricity do apply and depend on how far you are away from the server, can be up to 750,000 VD. Search for an affordable solution. Since a majority of the people living in the district cannot afford to pay such high prices, the need has arisen for developing a long-term, low-cost, sustainable energy solution which is appropriate to the environment of the Mekong Delta region. The preliminary design areas that were identified were solar power, wind power, and a combination of the two areas of solar and wind power generation. We considered the option of a hybrid renewable energy resource for our design project, as it is the most economical long-term solution for the people of the Mekong Delta. This system will employ solar panels and wind power to generate electricity. Design considerations. The hybrid system was considered appropriate with regard to the people's economic situation and because of the climate of the Mekong Delta region. 2/3 of the year is monsoon season when it's overcast and raining, so there won't be enough sunlight to generate a satisfactory amount of electrical power. Consequently, however, this will also mean that wind speeds tend to increase, and this will be adequate for the wind turbines to cover the shortfall and even sufficient to replace the solar panels as an energy generating resource entirely during this time. The remaining 1/3 of the year will be hot and sunny, but the electricity is turned off in summer, hot season from April to July, for about 1 day a week during daylight hours. So with this system, the people of the village will have the added benefit of having access to an abundant energy resource which will be available 24/7, so we will not be at the mercy of corporate control. The design will incorporate a wind turbine and solar panels that are designed to be upgradable or scalable. The wind turbine and solar panels will be connected to their own separate controllers housed in weatherproof and watertight compartments that will feed power to charge a bank of batteries. The inverter will convert the low voltage DC power into a higher voltage AC supply suitable to power external loads. System design specifications. The inverter is designed to be zero or very low maintenance. It will have inbuilt protection against low battery voltage to protect and increase battery lifetime, overheating, short circuit, overload protection. The batteries will be deep cycle sealed lead acid gel that are maintenance free. The charge controllers in the system will shunt power from the solar wind generators to the batteries when the power generated falls below a set threshold of output, and the excess power generated will be used to charge or top up a bank of batteries. The battery bank is designed to feed the loads up to a certain number of days with no sun or wind, depending upon the system requirements. This power will be sufficient to power loads, example water pumps, air conditioners, refrigerators, etc. Sourcing of materials. To keep the costs down to a minimum, parts for the wind turbine system will be sourced from CS Wind, a local manufacturer of wind turbines in Vietnam. The solar system, comprised of solar panels and maintenance-free gel batteries, inverter and charge controllers, will be sourced from a local Australian distributor of solar systems, Eurosolar. Environmental benefits. The obvious and most significant environmental benefits of this solution includes a reduced demand for electricity from power stations, which will minimize carbon dioxide emissions and pollution into the atmosphere, reducing the greenhouse effect that contributes to global warming. Opposite, you can see a chart showing average annual growth rates in carbon dioxide emissions for several countries, including Vietnam. Economic and social benefits. With a possible government grant or subsidised loan, the system will pay for itself in a very short time, and in the long term, this solution will be economically well suited to the people in the Anmin district, as it will be providing free power 24/7 for the community to use for a variety of purposes, including lighting, pumping water, communications, refrigeration, etc. By sourcing the components locally, we will also be helping to support local businesses. Cultural benefits. The cultural benefits will include a greater use of communications resources, including radios, television, telephones, satellite TVs, etc., giving the people more opportunities to learn from information they may never have had, and interact with other people and be better informed and educated on a more regular basis, since the power required to operate these devices will not be billed for. Some possible impacts of the solution may be a refusal of the government to adopt a new system that it will regard as a non-profit venture, as it cannot tax the people for using the power of the sun or wind, so it may reject any grants for the proposal. People may also be confused or surprised that they are getting power they don't have to pay for, and may think that there is a catch involved, as they have always been paying for their utilities. The major consideration is distributing the power equitably, so that everybody in the village has equal access to the power being generated. This can be accomplished by implementing a load controller so that the power can be distributed evenly where and when it's needed. This could also be achieved by capping the power used by any one dwelling to a specified kilowatt hour per day. However, this will all mean that the system will require greater initial investment to establish. Another ethical issue may be that people could be deceived by unscrupulous persons into paying for the power they use when in fact it should be free. In conclusion, we look at the system as a scalable long-term solution for a global problem. This problem will only be resolved if we all contribute to finding and implementing sustainable solutions, and in this context, currently planned solution design will need to evolve to develop into a robust and dependable source of power that the entire community can use to their advantage without depleting natural resources and contributing to climate change that can compromise the welfare and security of future generations. Thank you, and I hope you enjoyed my presentation.